So thanks for sticking around last session of the day. I promised to try to make it a good one. I'm actually pretty excited. Today is my 1-year anniversary with Amazon. Thank you. Not yesterday, not tomorrow, actually exactly 1 year today. And during the last 12 months, I've actually had a good opportunity to talk with a lot of customers like you, and a few common things come out. One, projects tend to start off really small, but then grow really fast. And one of the challenges with that is, as you go from one developer to two to hundreds of developers, how do you share and delegate access to that AWS account that you have? So that is what we're going to talk about for the next 60 minutes. I am going to try to keep it lively. I have a lot of demos, so hopefully that will keep you guys engaged. I know it's been a long 2 days. So with that, my name is Jeff Weir, and I'm a Principal Product Manager on the Identity and Access Management team. Do I need to switch it over to the slides? There we go. So before we get started, a couple goals for this talk. Really two things that I want you to walk away from this. One is a good understanding of the technology that you need to use to delegate access to your account. Specifically, the heart of this is something we call sessions. And I'm going to use a couple different terms for this throughout the presentations. But it's basically the temporary security credentials that you get from the Security Token Service, or STS. There's a couple different ways that you get those temporary credentials. We're going to look at roles, how you can assume a role. We're also going to look at Federated Sessions. And then towards the end of the presentation, I'm kind of giving you a comparison of when to choose which between them. Now, there's a bunch of different ways that you can use sessions or temporary security credentials, but we'll look at cross-account access, doing delegation at the API level. We'll also look at API federation. And to kick this off, I'll actually give you guys a demonstration of how you can single sign into the AWS Management Console using federation. So with that, I promised I'll try to put in as many demonstrations as we have. So the thing I would point out about this first demo is it's published, and you can download it, and you can play with the source code. So the URL is there. Please take a photo. It's also, I've put this through the slides, so if you don't remember the long, ugly-looking number at the end, you can always grab it. But the way this demo is going to work is I'm going to log into a Windows desktop. I'm actually going to do this in EC2. Inside there, I've deployed Windows Active Directory, so I'm going to be authenticated as a user in AD. I'm going to hit an internal proxy server, and that proxy server is going to present me with a couple of different roles that I can assume to log into the AWS Management Console. So I'll choose the role that I want to take, and I'll be logged into the Management Console. And I'll do this without having to have a username and password or having to create an IAM user to do so. So let me show you what this looks like. So the first thing, like I mentioned, if you're interested in playing with this yourself, you can go to the sample site. You can download it. Included with the sample is full documentation. It's actually a Visual Studio project in C#, if you're familiar with that. But also, if you're not a developer, you're not interested, and you just want to evaluate it, there's actually a simple MSI that we created for it as well. So you can go through, run the setup, simply give it a site name, where you want to store it. If you're going to use HTTP or HTTPS, I would go through the wizard. It would create it. Like any of those good cooking shows, I've already deployed this, and so you make the batter, you put it in the oven, you pull out the cake 60 seconds later. So I've already deployed it, and I have my console proxy sample running here. So if I browse, it's going to come to this portal, and it's going to give me this drop-down with available roles. So a couple things I'll point out here. One, it knows who I am. So I've logged into Windows, and using integrated Windows authentication, it's able to determine what my username is. It's also provided with me with a couple of roles that I can assume to log into the console. Now, where do those come from? So inside of my account in Identity and Access Management, I can switch over to the roles. And in there, I've actually created two roles. One is AWS admins, and one is AWS S3 users. And inside of Active Directory, if you're familiar with Active Directory, I'm going to go into the AD Administration Center. I can look up myself, and in there, I'm a member of 2 Active Directory groups of the same name. So what happens when I hit this site is it looks up who I am using integrated auth. It goes and finds out what groups I'm a member of in Active Directory, and then it does an intersection with the roles that are in my account. And I can simply choose the role that I want. In this case, I'll choose AWS Admins, click Sign In, and now I'm logged in. Didn't have to put in a username, didn't have to put in a password. I simply log into my account. There's a couple differences I'll point out, like visually here, instead of it having my name, it's actually showing that I assumed a role and the name of the role that I have, and it's a bit truncated, but there's a little other text in there in terms of my user ID and the Windows domain that I logged into. So I know I did that kind of fast. And some of you may be asking, okay, wait a minute, what just happened? So to reiterate, I logged into my Windows desktop. I hit an intranet website. The proxy server is sort of outsourced the authentication piece to AD. So there's no need for me to enter in another username and password. I chose the role that I want. Basically, it determined by entitlements by intersecting the Active Directory groups along with the IAM roles in my account. Once I selected that and sign in, I'm automatically signed into the console. So how did I do that? For the next 52 minutes, we're going to figure out how that was done. So let's start with the basics, and that's sessions and the AWS Security Token Service. So a little bit of Sessions 101. So sessions are really the heart of how you do delegation. They provide the temporary access to your AWS account. Sessions are generated by STS, which I mentioned, and they include temporary security credentials that you then use to make signed API requests against AWS resources within your account or even within another user's account. So how do you go about requesting a session? You can think of STS as sort of like a ticketing service, okay? You make a request from STS, and in the response, it creates a session. And the session has a few different parts. First are the temporary security credentials. This is your access key ID, your secret access key, and your session token. You use the keys to sign the AWS Service API requests the same way you use long-term credentials. Today, you're probably either using your root credentials or you're creating an IAM user and using those credentials. The only difference when you're using a session is you have to append the token. And the token is what allows us to verify that those temporary credentials are actually still valid. So in the case of S3, you would append that using the HTTP header. For all other services, you're probably using the SDK. You simply set the security token parameter to the session token. There's a number of different ways to get sessions. There's self-sessions using the get session token. As the name would apply, you're literally creating a temporary instance of yourself. It's mostly useful for things like if you're using multi-factor authentication and you want to make API requests that require an MFA one-time token. There's also federated sessions. You get them using the Get Federation Token API. And then we have assumed role sessions using the new Assume Role API. The first one really is about self-sessions is for yourself. It's not really delegating. The other two you can use, like with other users. So that's going to be where we're going to focus the rest of the presentation is really on how you use Get Federation Token and Assume Role to create those temporary credentials. Now this is important. Sessions expire. They are, after all, temporary. And the expiration actually varies on the token type. So you'll notice the minimum lifetime that you can have is 15 minutes, regardless of the session type that you chose. If you're using a federated session, by default, those are they last for 12 hours, though you can specify them when you create them to have a lifetime up to 36 hours. Assume Role are a bit more privileged, and I'll talk about that later in the presentation. And so therefore, the default is 1 hour, and the maximum timeout is actually 1 hour for those as well. You want to make sure that you use caching to improve your application performance. So a lot of people, as they're learning around how to use temporary security credentials, there'll be samples where it says, make a request to STS, get those credentials, and then make a signed request against another API. And a lot of developers go and they copy that code, and they just, every time they make an API request, they request another set of temporary credentials. Now, obviously, if your credentials have a lifetime of 36 hours, you don't need to make that API request, but once every 36 hours. I see this pretty much daily. You'll start seeing people who will go and make a couple million calls. You get on my naughty list. I'll send you an email, and I'll probably call you, and I'll go through this whole caching thing. So it's important that when you're doing this, that you're checking the expiration of the credentials that you're using, and if they're still alive, you don't have to request another session. So let's start with, let's get into role-based delegation. And since roles are pretty new, I always like to go back to what is an IAM role. I mean, how many people here are using roles today? Okay, so going through a tutorial on what a role is actually is pretty useful. So a role you can really think of as an entity or a container for policy. It defines a set of permissions for making AWS service requests. Role is kind of a tough name because when people think role, they think group or they think role-based access control. In this case, an IAM role has nothing to do with users or groups. They're not actually tied to a person, right? It's an entity. Roles are assumed by users in other roles. Okay, we call those trusted entities. And when you assume that role, you inherit the policy and permissions that are associated with that role. There's one caveat there. You can't use the root account. So root accounts, by default, don't have policies, right? They have full access. So root accounts cannot be used to assume a role. I'm sure that you're all still a little bit wondering what a role is, so don't worry. We'll go through and we'll have a deeper discussion of how to use them. So when we launched roles, it was really the first purpose was something we called roles for EC2. And this solved the problem of having to rotate credentials on your EC2 instances. So a lot of our customers, right, we boot up virtual machines in EC2. Inside there you have code, your own service code, and a lot of time that code has to access other AWS resources. So how do you do that? If you're following best security practices, you're creating an IAM user, you're creating credentials, and then you're rotating those credentials. Pre-roles, that is what you had to do. Everybody rotates their credentials, right? Multiple times a day, right? Lie to me. Tell me that you're doing it. Okay, if you're using a role, you don't have to worry about that. You go in, you create a role, you create an access policy on that role. Maybe you want to give it read access to all your S3 buckets or something like that. You go and launch an EC2 instance, you specify the role, and then behind the scenes, we'll create temporary credentials for you. We'll make them available to all those instances that are launched with that role. We'll rotate them multiple times a day, and best of all, if you're using the SDK, it will transparently use those credentials. So you don't have to worry about getting credentials out to the instance, you don't have to worry about rotating them, you don't have to even worry about specifying them in your code. There's something called the metadata cache, and it's just, the SDK will pull those up there automatically. So let me show you how to create a role and launch an instance. So I'm in the management console, switch over to the roles in the IAM tab, go ahead and create a new role. I'll call this one my AWS Summit demo. Now there's two types of roles that we have today, service roles and cross-account access. I'll show you the cross-account access one later in the presentation. But what you're doing here when you create a service role is you're saying, I want to create a role, and I'm going to delegate that service to have access to that role. So I'll choose the first one, which is EC2. And then I'll play a little bit of, I don't know, policy roulette. What's got a good policy? Yeah, we'll just select one. There, MapReduce has a decent policy. So we go in here, and this is the access policy, which allows, oh, that's kind of annoying. Let's try that again. That's a less impressive one, but Nonetheless, no, I don't like this at all. Relaunch the browser, see if I get a better resolution. Test. Power user. There we go. Continue. So I've created my role. Now what other people do is they don't go back and actually look at what that creates behind the scenes. So it actually, the policy you already know, right? This is an access control policy, and I'm sure you're familiar with the access control policy language that we have. But it actually creates another policy in there that we call the trust policy. And so if I look at that, this is another policy in here where we specify a principal, and in this case it's service, and we've delegated access to EC2. And we've delegated access so that they can call STS assume role. I'll explain a little bit more what that means when you specify something that isn't a service like another AWS account. But there's actually two policies that are associated with that. Now if I go over here and switch to EC2, I'll go ahead and launch an instance. Select the good old Amazon Linux AMI. Team Micro. Go big or go home. Continue. And then this is the only thing you need to do, is go down here and specify the role. And now when I click continue and I go and deploy that bad boy, credentials are going to be made available to it. There's nothing that I need to do in terms of getting those keys out there. Now I'm actually not going to launch that instance because that's a ridiculous size for a demo, but that's as simple as it can get to launch an EC2 instance. So if you're not already using roles, if you're still using long-term credentials on your EC2 instances, this is the way to go. So some of the obvious benefits of using roles, well, as I mentioned before, it eliminates the use of those long-term credentials. We do the automatic rotation, so if you did write code that was rotating it or you were manually rotating it, you no longer have to do that. And it actually eliminates the amount of code that you need to write because the SDK is going to pick up those credentials automatically. So you don't have to be putting them somewhere on the file system, encrypting them, pulling them off the file system, decrypting them, and going through that whole routine. So that's one use of roles. It's actually where we first launched roles. In November, we actually added something we called cross-account API access. Here I call it API account access. And this is going to allow you to access resources across your AWS accounts. Now, turns out many of our customers have more than one AWS account. They'll have a production one, they'll have a development one, they'll have a staging one. I know customers who have hundreds of AWS accounts. And, you know, when you have multiple accounts like that, management visibility across all of them can be difficult. You can imagine having 100 accounts and having to log into the management console 100 times to see views across all of them. Also, if you're a developer, maybe you have full access to development staging, but you only want them to have read access to production data, right? Third, and not least, is using third-party management tools. So I know a lot of people manage their AWS environment using resources from our partners. Now, you can go and you can create long-term credentials and hand them over to that partner if you trust them. Or, if you're using roles, you can simply say, here's a role, assume it, and when you're done, maybe you don't want to use them anymore, or you've terminated the relationship, you simply change the permissions on the role, or you delete it, and you don't have to worry about any long-term credentials that are out there. So, a number of different reasons why you might want to delegate access across AWS accounts. And to enable this, we really extended that roles for EC2 concept. So there's two policies on the role, right? When you created the role for EC2, we focused a lot on the access policy. What can you do with that role? But then there's also the trust policy. And it's in the trust where you delegate access to other AWS entities. So we looked at the service one, we looked at EC2, but I could also delegate to an IAM user within my account, or I could delegate to another role. You can have roles that call roles, and those can be within your account, or it could be from another account as well. And so with this, you could have an IAM user in one account who can access any of the resources. You could have a single set of credentials to rule them all that has access to every AWS account that you have. And the way you do this is you go in and you create a role, and you choose the role for cross-account access. And when you go through that, you're going to end up creating a trust. And this is what that trust will look like. So in here, you're allowed to assume a role. And here is the ARN of the role. Actually, this is the policy that goes in the IAM user. The next slide actually describes this a little bit better. So let me paint the scenario here. Say I'm Jeff, because I am, and I have my AWS account, and I work for the IAM team, and the IAM team has their AWS account. This is actually really how it works. And we both have resources in our accounts, but I want to be able to read not only the buckets in my account, but all the buckets that are in my team account. So to do this, I'm going to create an S3 role in the team account. And the policy on that role is going to allow me star access to all S3 resources. So I'll essentially be God of S3 inside the team account. And on there, I need to add a trust. And in this trust, I'm going to specify that this account can assume this role. So this is half the equation. The other half of the equation I actually have to create in my account. So in my account, I have to create a user, Jeff. And Jeff will have that policy that says he can call assume role for that role that I created in this account. And what will end up happening is I'll authenticate using keys for Jeff, the user, in my account. I'm going to get back a set of temporary credentials by calling STS and using the S3 role. And then with those temporary credentials, I can make API requests against buckets in the other account. So let me show you how this looks in the wild. So here, not that one, this one, yeah, that's my role. Let me get that in my clipboard. So I'm going to launch a sample amp that I created. Never tried to create a demo the day before. I was up pretty late last night writing this. And in here, I'm looking at all the buckets in my team account. So probably makes sense to bring this up in a browser so that you can see these side by side. So I'm going to go to S3. I'm actually logged into my team account over here. And you can see here are all the buckets for my team. And the way I got to them is I have my access key and secret key, the Jeff keys, and I'm assuming this role to get all of them. Now, I have multiple accounts. So what if I want to see all of those buckets across all the accounts? Well, I can go in and I can keep adding roles. Oh, I love it when that doesn't work. Let's try the clipboard again. All right, clipboard is working again. So I'll go in, add another role. Okay, maybe it's not working again. Say again? I'll take part of it and see. Yeah. Good call. Add in another role. Now I can browse through them, and I can just keep doing this. And yes, you could use multiple credentials. I could have created IAM users and have credentials for each of those. But the nice thing about this is I have one set of credentials I need to manage, and I can go through and I can continuously see, like, for example, here's photos of my kid. She'll come up. And using the same set of credentials, I create a temporary session, and I can go over and I can browse the bucket over here, and I can open up text files. Thank you. You'd be surprised how many times people don't clap for that. And so if I have more accounts, you could see how I could just keep adding them on there, and I would have one place to go and see all the data that is across all my accounts. Now, this is an example for S3. Obviously, if you're using something like EC2, the same premise would apply. You can go in, you could see all the virtual machines across test, prod, and staging, development, any of the environments you have. Now, as I mentioned, the code for that looks pretty ugly right now because I was working on that up until this presentation. And so here, I'm going to call out what I think are the relevant things. One of the things I always try to do is have code that you could copy and paste into your application. So this was a C# example. And you should be, if you have an access key and you have a secret key, you should be able to create a session and get back temporary credentials that you could use. And so what I'm doing in here is I'm making an assume role request, specifying a duration of 3600, 1 hour, the maximum, putting in the ARN of the role that you're going to assume, and then you can give it some name. Later on in the presentation, I'll talk about scoping down, so you can actually attach a policy if you want to scope down the permissions of that. I don't have that in the sample here. And when you get back the request result, that will actually have the temporary credentials, right? The access key, the secret key, and the session token that you then can use to access S3. And that's as simple as it is. So some of the obvious benefits of there, I'll reiterate, only one set of credentials. So on my machine, I only have one set of credentials that are encrypted for that application. I don't have to share long-term credentials with any of my business partners, any of my coworkers. I simply create a role and I say, assume this role, and you should get temporary access for the next hour. And the great thing about that is I can revoke access to that role anytime I want. I can change the permissions on that role, I can delete that role, and when I do that, their temporary access is actually eliminated. So let's talk a little bit about federation, sort of a twist on the cross-account API access. So for those of you who are new to federation, this is sort of outsourcing the authentication piece to AWS, right? It's how you access your AWS resources using your existing corporate entity. And we took a look at the very beginning, we took a look at how we could do this to log into the management console, right? But you could also build applications that transparently access AWS resources and APIs. Maybe you want, a little service or some type of application that runs on every one of your users' desktop that creates a home folder in S3 and copies that up there on their behalf, and they don't want to have to go in and log in with AWS credentials to have that do it. You want it running kind of as a background service, right? The other nice thing about it is it eliminates yet another password to manage. So I already know how to log into my workstation. Why should I have to remember another username and password to get to all the resources I need to do my job? So the first case we'll look at is API federation. Just like the management console, this is actually a sample that we published. So if you want to download that sample, you're free to work and play with the code. This is based on Windows Active Directory. So we're assuming that the users are logging into Windows. In this case, the privileges are going to be based on AD group membership. So similar to the management console, we'll go and we'll see what groups they're a member of. And then on the AD groups, I actually store policy snippets. And I'll show you how I did that. On the other end, I'm using the relying party as AWS. And we're going to look at how we can access the S3 APIs using temporary security credentials. And in this case, we're getting those temporary credentials by making a get federation token request. So different API. We're not using roles in this scenario. To kind of walk you through it, I'll have a command line application. And that command line application is going to be talking to a web service that's running on a proxy server. You can think of it as inside my enterprise. And that proxy server is actually going to use a set of IAM credentials. And those credentials are going to be used to make a get federation token request. The way that get federation token works is when you make that request, by default, you get the privileges of the user. So if that user is an admin, the resulting temporary credentials will actually have admin access. Now, when you make a get federation token request, you can scope those down, okay? And I'll show you how you can attach a policy to scope those down. Now, let's say that the IAM user using at the proxy has S3 star access, right? I can't attach a policy that elevates privileges. I can only scope down privileges. So if I give S3 star access, I can go to S3 read access, but I can't give them, administration access or access to IAM APIs or something like that. So typically, if you're going to have a bunch of users who are sharing this proxy server, the IAM credentials at the proxy server probably end up being pretty privileged. because they have to be the union of all the privileges of all the users. And if you have one admin in your group, the proxy server is going to have admin privileges for those credentials. So you want to make sure that you secure those, encrypt them, make sure that the proxy server is pretty hardened. You don't want those credentials to be stolen. So I'm going to make a request. The user is going to be authenticated against Active Directory. I'm going to look up the groups that they are in Active Directory and determine their entitlements. I'm going to make the get federation token request against STS. STS is going to give me back the temporary credentials in the form of my keys and my token. I'm going to take those, that session, and then I'm going to make API requests against S3. So let me show you that. So the question is, and I should have mentioned this at the front. I'll answer your question, but I'll generally take questions at the end just because I think I'm going to use up every minute. The question was, can the API work against Active Directory? Can it work against any LDAP directory? The answer is that you can outsource it to any directory. It's not an AD specific thing. I use it because it's a pretty common case. But basically, in Federation, you're outsourcing it to any trusted identity provider. So once again, let me go and just show you the configuration first. If I go in here and I look at Jeff, Jeff's a member of this AWS S3 users group. I showed this group before. In this case, I'm using a little bit of a different trick. There's some unused attributes in Active Directory. One of them is the Aws Security identities. And in there, I've actually stored a snippet of policy. It is absolutely impossible for any of you to see that. So this is what it looks like. It's a snippet because it's not well-formed JSON. It's just a little bit, and I'm going to use that to create a policy when I make the request. And you can see I have kind of placeholders in here that the proxy will replace. So if there's a specific bucket based on my username, or there's a group bucket, I can go in the proxy server and I can customize that policy. Now to demonstrate this, I have just a console app. So I'll launch that. And the console app is going to actually talk to that web service. So the proxy server is actually exposed as a Windows Communication Foundation service. And I'm going to call that. And it's going to get back a set of temporary credentials. And it's pretty fast, you can see. And when I have those credentials, I can go through and I'm listing that same bucket. And so I can put a file to pull down. Actually, pull that down. And if you're able to read that text, thank you. You guys are actually alive at the end of the day. And voila, I'm able to read that. Now, what's actually happening behind the scenes? This is where high resolution actually is beneficial. So first, when the console application hits the proxy server, the first thing I do is identify the user. So I know who I am. It's using Windows Integrated Authentication. You can replace this with any authentication system that you want. And all I'm doing there is I'm grabbing the username. The next thing I'm going to do is I'm going to go and I'm going to create the security token. And this is just a function which calls get federation token. So in here, there's a couple things I'll point out. One, I build up the policy. So this is a helper function over in utilities here where I basically go through and I iterate through all the group membership. Once again, it could be looking at an LDAP group membership. And I go in there and I pull off that piece of policy snippet if the group has it. And I concatenate that to create a policy. And so when I make the get federation token request, this is the relevant piece of code here, I'm setting the duration and I'm setting a name for it just like I did when I was creating the session with the role. But here I'm attaching a policy to scope it down. So the IAM user here, in my case, when it's making the request, does have admin privileges. But because I'm passing this policy, the resulting temporary credentials will be good for 8 hours, and they will only be good for accessing the bucket resources that I specified in that policy. And so this is how you give individualized or very custom permissions to those federation users. Okay, so that's one type of federation, and basically the same code. The one I showed in Visual Studio was pretty clean, but here's another working sample if you want to copy and paste it into your application. That's one type of federation. Now, you can use temporary credentials from an assume role request or a get federation token request to perform federation. So assume role sessions can also be used. It provides sort of a different option for storing the permissions. And this basically comes down to how the privileges and the permissions are generated. So as I mentioned, when you do a get federation token request, the permissions are derived by the IAM user that's made the request and scoped down by the policy. So typically, you're going to store those permissions inside of your enterprise like I did. I stored them on Active Directory objects. When you use roles, it gives you a sort of a different option because the policy is actually stored on the role. So depending on how your organization is organized, you may have, hey, I'm the administrator and I own everything, and so I want to keep all those privileges inside of my enterprise. And so maybe get federation token is a good option for you. You may have an organization where we have our Active Directory administrator, and they don't have access to AWS, and we want to have a separate administrator, and they control all the privileges to AWS. In that case, you would want to create roles, because the roles actually are the container for the policy. And so there's this separation between the two. So it's another option that you can use for federation. So going back to the console federation, and here's that URL again if you didn't have a chance to write it down. This is a similar scenario where we're going to use Windows Active Directory, though you can replace it with any directory. The privileges are going to be based on AD group membership, but instead of getting the policy off the group, we're going to match the group to roles that are in my account. And so the policy won't live in AD, the policy will actually live in IM. And in this case, the relying party is going to be the AWS Management Console, and we're going to use the assume role API. So to set this up, this is it's sort of like the cross-account scenario, but within my account. So in there, I'm going to create some roles. Once again, I'll create an S3 role because we've been using that throughout the presentation. I'm going to create a trust policy, but in this case, I'm going to change the policy a little bit to add a condition. So in this condition, I can specify an external ID. Okay? So what I'm going to do in the proxy server is I'm going to look up the user, and the user is going to choose a group. And I'm sort of going to do a matching on it, a forced matching, where I grab the SID, the security identifier of that group. So if someone goes and deletes the group, it recreates the administrator group, you get a new SID. So by specifying the SID as a condition in the role, that will guarantee that if anything funny happens in Active Directory, this role will break. So it's not like someone can go in and create a group and all of a sudden get privileges based on a simple name matching. So this is a security session. Thought I'd mention that there's some additional security best practices you can do on that. And then over in my account, I have the proxy user. And this proxy user is going to have the privileges to assume a role and to list all the roles. And that's all the privileges that proxy server needs. You'll notice in this case, it doesn't have to be a super user because it's getting its privileges from the role that it's assuming. So the proxy server will authenticate with STS. It will assume the role. It'll get those temporary credentials. And it's going to use those temporary credentials to log into the management console. This is the simple case. This is the longer one. So the user is going to browse to the proxy server. Once again, the proxy server is going to have IAM credentials, but it's going to have limited rights to call list roles and assume roles. So even though it seems like those are just two APIs, it's still highly privileged. You should still encrypt them, and you should secure that server. It's going to authenticate the user against the corporate directory. It's going to enumerate the groups. It's going to call list roles. It's going to get back a list of all the roles. It's going to do an intersection. It's going to populate a combo box. You guys saw that if you were here for the beginning of the presentation. It's going to make an assume role request. It's going to get back a set of temporary credentials. It's going to generate this funky looking URL, which will redirect you into the management console. Now, if you're interested in doing this, I highly recommend you download the sample because we've completely documented this. There's a bunch of set of classes that you can use, and you don't have to reinvent this if you want to do it. So we took a look at the final product. Let's go ahead and look at it. What's happening behind the covers. So I'll start up my project here. Here's the list. So it's already gone in and authenticated me in Active Directory. It's called list roles. It's done the intersection. In this case here, I'll choose S3, sign in. And the first thing we're going to do is we need to get those temporary credentials. So we'll go ahead and we'll let it move forward. The way it gets those temporary credentials is making an assume role request. So in this case, I'm going to do the maximum of 1 hour. I chose the S3 user, so there's the full ARN for it. That's my username, so it knows it's me logged into that domain. And there's the SID of the group. So all of that needs to be passed in with the request. If I didn't put in this external ID, it would actually give me an access denied. So I'll go ahead and play that through. This is where I get a bunch of keys. This is where I keep playing and don't hover. And then over here, we have to create this sign-in URL. So there's a whole set of code in here that goes into creating that sign-in URL. First thing you do is you have to create a sign-in token. And then we take the sign-in URL. It's a little bit easier to look from here. We take the sign-in token. We take the issuer URL, which is the application that made the request. So after my session expires, I'm going to get kicked out of the management console, and it needs to send me somewhere. This is the URL that it will send me to when my session expires. And I need to know where I need to land. I'm going to land in the management console when I first attempt this. And so the end product of this is the sign-in URL, which is a really long URL. And what this does is it gets sent back to the browser, and the redirection happens typically so fast that you're signed into the management console, and you never actually see that. Sign-in URL is actually, you should trust it as a secret because it has all the things in there. If I were to like mail it to you, you could sign in as an administrator into my account. But I chose the S3 role, and just to show you, if I go into IAM, I'm going to get not authorized, but if I go into S3, okay, that's awesome. If I went to S3 and I had the latest Java installed, it would show me the S3 console. So once again, I always like to show a little bit of code that you can use. If you're using the sample, it's actually very compartmentalized, and there's lots of classes, and it's broken up. But if you wanted to just play with it, this is a single method that you could use. You pass in the credentials, the issuer URL, the console URL, and the sign-in URL, and the output of that will be a login URL that you can use to single sign in. So a useful function if you want to play with that on your own. Some of the obvious benefits, you get to leverage your existing corporate identities, right? Your users don't have to remember yet another username and password. The nice thing, too, is you get to enforce corporate policies and governance. So if you have extremely strict rules on usernames, they need to be rotated every 30 days, they need to be 20 characters long, right? You can enforce all that stuff, and you don't have to worry about creating an IAM user with that same sort of restriction on there. The other thing, too, and this comes up more than you would think, when an employee leaves, you only need to delete their corporate account. We get calls from people who are saying, oh, we let Joe go 2 weeks ago, and we forgot to delete his IAM account, and he's been wreaking havoc on our AWS account in the 2 weeks which he's been gone. Here, they leave, you delete their account, you've effectively revoked their permissions to AWS. So it's another benefit worth pointing out. Okay, here's another feature that we actually released earlier this month that I wanted to mention because it's a different way of delegation. We've talked about cross-account access, and we've talked about federation. This is a little feature that we added that allows variable substitution in the policy language. So let's imagine you are creating, you only have a handful of people, so you're not going to use federation, you're just going to create a handful of users, IAM users. And you want to have, very granular permissions on those users. So for example, maybe you want them to be able to manage their own credentials. They should be able to rotate their own keys, they should be able to create their own passwords. Maybe you want a home folder where they can store all their documents somewhere in an S3 bucket. Or maybe you even want, personal SNS topics or SQS queues. So before variables, you would actually have to create a very explicit policy that named all those resources. And on just earlier this month, we allow you to take any of the keys, so AWS source IP, any of those conditional keys that you use in policies, they're now exposed as a variable. And we also added additional ones for AWS username, AWS user ID, and principal type. So over here on the right, I've created a policy that I can put on a group that will give everybody in that group a home folder in S3. And instead of having to create a new policy, with Bob, with Jim, with Jeff, or whatever, I simply add users to this group. And when they go and try to access a resource, the portion in red is the variable gets replaced with whatever value is in there. So I think this is actually one of them that demos better. Actually, let's do that from here. Yeah, okay, let's do this from here. So I'll do these side by side again. So in my account, I have a user, and the user is Bob. And using the old method, I'll go in and I'll look at the permissions on Bob. He's got a policy that gives him access to his own S3 bucket. Bob's lucky, he's got his own S3 bucket, right? And so you can imagine if I had to keep adding users and creating buckets using this method, I'd pretty soon run up to the 100 bucket limit. So what I really want to do is customize this so Bob has a home folder. So if I log in as Bob, I know that this one has the latest Java. Although the internet is not my friend here. Bob, there's a bunch of buckets. Bob can log into his bucket, but he cannot log into the other buckets. And what I really want him to do is to be able to log into this user's bucket where we have home folders. So what I'm going to do is I'm going to actually remove that policy from Bob. And instead, I'm going to move over to a group. And here, I have my S3 users. And I'm going to add Bob to that group. And if I go over here and I look at the permissions on this group, it's a little bit, maybe a little bit hard to see given the resolution, but I'll give you a little bit more room. Just to explain what happens in this policy, this is sort of a boiler template. If you want people to be able to see all the buckets from the management console, you're going to be giving them this privilege here. It's probably one of the more frequently asked things of me is how do I let people access the management console? And then this bit of policy here allows them to see the home folder within my users bucket. And then down here is where the magic happens. So within that bucket, I'm going to have a home directory with every user's name using that variable. And then within that resource, right, both within that folder and any subfolders, I'm going to give them full access to it. And so now if I go back to Bob, you can see I cannot log into other buckets. I can now go into the users bucket. I can go into the home folder. I can't go into Jeff's folder, but I can go into Bob's folder. And Bob can even download files. Anyone guess what's going to be in this file? Any good comedian comes to the same joke 3 times, right? So, and that's a variable substitution. So that's actually a very simple way if you're not dealing with federation, you're not dealing with delegation, you have a handful of users. Variable substitution is a great way to simplify the management of those users. So, 10 minutes left. I want to talk about considerations for when choosing the different session types. So as I mentioned, there's different ways that you can get those temporary credentials, and depending on the API that you call, there's a different way that the permissions for those credentials are derived. There's a couple other factors that you should consider. One are what services do you want to use? Not all sessions were created equal, and not all services support temporary credentials, and so it's important to know that. In fact, there's a couple services that don't support temporary credentials at all. So in that case, if you're using one of those services, you have to use long-term credentials. So keep that in mind. The other one I mentioned before is where do you want to maintain those permissions? Are you an enterprise that wants to maintain all those permissions inside of your corporation, or do you have a separation of powers where you want to have policy in AWS and users defined? So that's another thing to consider as well. So this is sort of a chart on what services support sessions. So most services support both federated and assume role. It really comes down to these handful. So when you're using federated, this is the get federation token API, you're not going to be able to call any of the security token service or the IAM. And we do that really for security purposes. Like, those are privileged APIs. And we don't want 36-hour temporary credentials floating around there that potentially could expose your account. Assume role, on the other hand, are time-bound. They're tied to an entity, the role. And so therefore, you can call the IAM APIs as well as you can assume a role. So when you create an assume role session, the temporary credentials you have can be used to call assume role. They cannot be used to call get federation token, because you can imagine someone creates an assume role session and then creates a 36-hour get federation, and they just keep extending the lifetime of that. And so once again, kind of for security reasons, we don't allow that. And then there's the three: CloudFormation, Beanstalk, and MapReduce. These are sort of meta services that do a bunch of stuff behind the scenes on your behalf, and because of that impersonation, it's going to take us a while to get those services to be able to support temporary credentials. So I point that out as if you're using CloudFormation or you're using Beanstalk or you're using MapReduce, you're going to be, if you want to manage those services, say from the management console, you're going to have to log in using long-term credentials. Those are the three services right now that you can't use a role or get federation token to manage those. And this is update as of 4:30. We have a list up there that shows you what is supported, and we're always changing that because new services are always coming online. Some of those services support temporary credentials on day one. Some of them take a little bit of time, so always go and look, is the service that I'm calling going to support temporary credentials? This is the other one that I mentioned. Do you want to store the permissions inside of your enterprise, or do you want to store them within AWS? If you want to maintain everything and you have a single administrator, you're probably better off using get federation token. As I mentioned, going through that scenario, the proxy server is going to probably require the maximum permissions of the union of all of your users. Typically that's star. And then you're going to attach a policy to the request to scope it down. So you're going to have to manage those policies inside of your enterprise, and you're going to have to attach that with every request. If you want to manage the permissions inside of AWS, using roles is probably an easier solution for you. If you use the proxy sample that I demonstrated, the proxy is only going to require list roles and assume role permissions. And then you can optionally attach a policy. So roles are a little bit more flexible in that if you want to, you could also store policy inside of your enterprise and scope it down. But in general, you'll probably be assuming one role for one set of entitlements. So in summary, we looked at a couple different use cases. One of them was the cross-account API access. I showed you how you could build a single set of utilities using one set of credentials where you can manage all of your accounts. You don't have to share long-term credentials with your users or even your business partners if you're using third-party tools to manage your account. And because this is based on a role, you can change the permissions on the role. You can delete the role at any time to revoke access to that. We looked at federation as well. So there, you're leveraging your existing corporate identities. You get to use the username and password that you already know and love. You get to enforce any corporate policies or governments or any specific rules that you have inside of your organization that you want to apply to your AWS resources. And best of all, employee leaves, gets fired, retires, wins the lottery. You should probably think of some positive examples there. You only need to delete their account, right? And so you've effectively revoked their access by deleting that one username. We took a look at some of the different technologies. I'll reiterate, sessions are the heart of delegation. You're going to use either the get federation token or the assume role API to request those sessions from STS. When you get those, you get your keys, your secret key, your access key, and your session token. You're going to apply it, and you need to specify the token. That's another frequently thing I see people do wrong, is they get the access keys from the session, and they forget to append the token to the request. So then we also start seeing in our logs a bunch of access denied. usually results in an email from me as well. So you make sure that you assign those, you assign the token to the request in there. And then last but not least, choosing the right session for the job. So with that, I'll put up some information on there. We have, if you want to get more information, we actually have the IAM homepage. We have a forum, so if you have security questions or you're having trouble with any of the samples that we have, or you just have a question on how to do something using the access control policy language, that is where I and a bunch of other folks on the team hang out. The developer documentation is excellent. There's actually another document in there for STS I should have put in there. And just this, was it last night? Yeah, just last night we launched the AWS Security Blog. So that's where we're going to be posting tips and tricks and things how you do it. So you can go over there and you can subscribe to our blog. I will leave this up, and I have like 4 minutes. So if you guys have questions, I'll hang up front. You can come and talk to me. And otherwise, thank you for your time, and thank you for attending the AWS Summit.